Hello and welcome back. In 11.2 we work on odds. Odds are a ratio of probabilities. So remember, a ratio is two numbers, a comparison of two numbers. So odds are always going to have two numbers involved. People paying math tax, odds are, when they're stated, are against an event occurring. With the usual caveat unless otherwise stated. So how we calculate the odds against an event. Again, it's a ratio, so it's a comparison of two numbers using division. So that would be the probability that the event does not occur to the probability that the event does occur. Sometimes shortened to probability of failure to probability of success. So we'll do a quick experiment. So our experiment for this one is that we roll a single die. Roll a die. And the event in question, let's see. Roll a 5 or 6. Then the odds against our event would be the probability that we do not roll a 5 or 6 to the probability that we do roll a 5 or 6. So that would be 4, 6 to 2, 6. So 4 to 2 reduces to 2 to 1. Which we would leave as 2 to 1. We would not call that a 2 because, again, we're looking at a ratio. Ratio has to be two numbers. So this would be 2 to 1 odds. Also sometimes written as with a colon there, or sometimes just written with the words. In math, we pretty frequently write it as the fraction as well. So that's our odds against rolling a 5 or 6. Notice that that's not going to be the same number as the probability that we do not roll a 5 or 6. Probability we don't roll a 5 or a 6 would be 4 out of 6, which simplifies to 2/3. So just as a heads up, odds and probability are not the same number. Just a good thing to remember when you're working in this section. So for example, let's say in the last quick short little word problem. In last election, 23 of every 100 voters went to the polls. odds against your randomly selected voter. Going to the polls. So eligible voter, not necessarily someone that cast a ballot. So we need two numbers. We need probability that the voter goes to the polls, probability that the voter does not. So 23 out of 100 went to the polls. 23 100ths would be our probability. So the probability that the voter does not go to the polls, there's only two possibilities. They either cast a ballot or they did not cast a ballot. So 1 minus 23 over 100. We have 100% of the cases minus the probability that they did cast a vote. So that would put us at 77 hundredths. So then the odds against would be probability that they did not go to the probability that they did go. So 77 23rds. Even though this is an improper fraction, we definitely would not turn this into a mixed number. We have a comparison of two numbers. These are relatively prime, so we don't have any reducing to worry about. So 77 to 23. We do still occasionally also use odds in favor of an event. If we're talking about odds in favor, success goes at the top, failure goes at the bottom. So for example, we'll find the odds in favor of selecting a face card. So again, we need two probabilities. We need the probability that we select a face card, probability that the randomly selected card is not a face. So face cards, Jack, King, Queen in every suit, so 3 by 4, 12 out of the 52 cards there, which will reduce to 3/13. They're both divisible by 4. Probability that we have not selected a face card then is 40 to 52, also both divisible by 4, so that would be 10/13. So the odds in favor of randomly selecting a face card, 3/13 to 10/13, which will simplify to 3/10. So 3 to 10. So remember, we can also write that using a colon or using the printed word 2. Alright, so I'm going to have you all try one out. So let's say in the same fictitious election, we had 3 candidates. Candidate A walked away with 32% of the vote. B walked away with 20% of the vote, and C walked away with 48% of the vote. Find the odds against randomly selected vote. Picking the winning candidate. Okay, so see if you can run through that problem. Go ahead and pause the video, unpause when you're done. Okay, welcome back. So odds against a randomly selected candidate, randomly selected vote picking the winning candidate. So we want basically the probability that we randomly selected a winner versus probability that our candidate was not the winner. Our vote was not cast for the winner. So 48% means out of 100. You'll hopefully know that by now. Percent literally translates to out of 100. Both divisible by 4, so this would be 12/25. Probability that the randomly selected candidate is not a winning candidate, 1 minus the probability that the randomly selected vote was cast in favor of the winner. So 1 minus 12/25 would be 13/25. So the odds against the single randomly selected vote picking the winner our winning candidate here was candidate C. Odds against probability that we did not select the winner out of the probability that we did. So 13/25 to 12/25. Or 13 to 12. Which again can be written either as the fraction with the colon or the word 2. Now we can also sort of reverse engineer some of these. We can find probabilities from odds. So for example, horse is given 3-to-1 odds in a given race. Now recall with the math tax problem, odds are against when they state the numbers. So this is 3-to-1 odds against the horse being the winner of the race. So we're going to find the probability the horse will win the race. So remember, odds against would be probability against to probability for. So 3-to-1. So there are 4 total events, 3 ways the horse can lose, one way the horse can win. So notice this is the sum of the 4 is the sum of those two. So we had 4 ways the experiment could end. 3 one way, 1 the other way. So think of 3 failure events. 1 success event. 4 total events. So then the probability, this was a 1, my apologies. Miscopied that. 1 to 4. So the probability for the horse winning that should be cap P. Probability of win would be 1 in 4, or 0.25, or 25%. So 25% chance that the horse will win the event. Just sort of working our formula backwards. So in, this is section 11.2. I would recommend 1 to 8 all and 9 to 59 on the odds. If you have any questions, please come see me. Otherwise, I'll see you next time. Stay safe out there.